Okay, welcome to another programming exam solution tutorial for the 2014 COMP1 card predict exam. I'm going to look at a solution for the Riffle. I think you remember that one of the tasks I proposed, and whilst I'll be honest with you, I'm not 100% sure this is going to come up. In fact, if it comes up, they will give you an algorithm because it's pretty hard. It's just very, very nice. I'm not going to go over this again. This is exactly what I set out in the tasks. You can watch the video for that. But I just thought I would go into a little bit more detail about what's going on. So I want to imagine we've got a complete deck, and then what we've done is we've taken the top half of the deck there and put it in an array called left, and the bottom half of the deck is an array called right. And then all we've got to do is feed this one back into there, then this one back into there. So this used to be the 26th card in the deck, and now it's the second. So we've now got the second one going into the third, and we've got the 27th one going into the fourth. Let's have a look to see what this looks like when it's coded. So I'm not going to code it in front of you, I'm going to just explain it. So I've obviously had to create a sub-procedure called Riffle deck, and I just have to pass it the deck. Make sure you pass it by a ref because we're going to be making changes to it. The only variables you need to define are the left and right cut arrays that are going to take the top and bottom of the deck, and I'm calling it left and right because when you cut the deck you nominally hold one in your left hand and the other in your right hand. This position will refer to the position of the deck. This offset is a sort of way of linking way of linking these numbers with this number, because if you think about it, I'll be going from 1 to 1, and I suppose that's left. I'll be then going from right 1 to 2, although we're going from left 2 to 3, and right 2 to 4. Now, if we kept on with this, you'd realise that there's a pattern forming. That for here I have a removal of 1 for this set, so apart from the first one, this is now a removal of 2. If we do it again, I'll be going from left 3 to 5, deck 5, and I'm going to be going from right 3 through to deck 6. So now I've got a shift of 3. And if you followed it, you'll see that actually it might have been better for me to start like that and link them like that. So this is a shift of 0, that's a shift of 1, that's a shift of 2, and this is a shift of 3. If I go left 4, we'll go to deck 7, and then right 5 goes to deck 8. Right 4, sorry, right 4. So now we're on to a shift of 4, and that'll be left 5 goes to 9, and you can see it there. So basically, the link between these numbers, this is a right mess now, and these numbers is an increasing offset. And the way I've handled that, the way I've handled that is using this offset variable. So the first thing that we do is simply zoom through the deck and take the top half and the bottom half. And I could have done this in 2 loops, but you might as well just do it in 1, because basically I'm going to have 26 cards in the left and right cut. This one will take cards 1 to 26, and this one will take 27 to 52. Simple as that. So you can do that nice and efficiently. I've now got 2 arrays, left cut and right cut. We now get to the sneaky bit where we feed them back in. And effectively what I want to do is go through the whole deck, and if it's position 1 I want to take from the left cut, if it's position 2 I want to take from the right cut, position 3 left cut, position 4 right cut. So effectively odd numbers will be taken from the left cut into the deck, even numbers of position in the new deck will be taken from the right cut. As soon as you see odd and even, you're going to be using mod 2. So if the if the value of mod 2, i.e. the remainder of a division of 2 is 1, then it's an odd number, otherwise it's an even number. So I'm using the fact that if it's an odd number, then feed the deck from here, and if it's an even, feed the deck from here. I'm only bothering to increase the offset on the even numbers because, as you saw last time, you have to take from both odd and even before the offset increases by 1. I strongly recommend that you have a go at that and step through the code and make sure that you understand it. If you haven't already created a little display deck, then you probably ought to, so you can test this really easily. I actually, in fact, created some. Where are they? Testing loops where effectively I ran the program a number of times. So I created an array with 10 columns with 52 cards, and then I looped through 10 times, and then I could look at the array afterwards, and then I just create a display array thing where I can actually look through to see how the riffle moved cards about within the new decks. And I'll leave that up so you can get your head around it and have a play with it. But as you can see, all it's doing. Oh, I need to point this out to you. When I did this, I realised that the Riffle doesn't randomise the cards at all. It's absolutely rubbish. So I looked again and I realised that if I always take from the left every time, then I end up not really randomising the cards very well at all. If it's a perfect riffle and you always take from the left, it's rubbish. So what I did was just alter the algorithm slightly, bang, and this time I noted how many times I've riffled. And if it was an even number of times that I'd riffled, then I took from the left cut first. If it was an odd time, then I took from the right cut first. So basically just swapped around the left and right cut in terms of which one went on top. and that actually became a very, very good riffle. Now, I guess if you wanted to take it further, you could decide whether you had exactly 26 cards in each bit of the riffle. You could say have a subtle difference between the left and right cut. It gets a bit trickier, but it'd be quite nice. So that's the code for you to look at. You've really got to have a go at it and just step through it and see what's going on. If you've got any questions, please comment. I hope you found it useful. I wanted to keep this one fairly short, and look forward to more solutions coming very soon.